If equation ax²+bx+c equal to 0, where a is positive, strictly positive, has two roots, alpha and beta, such that alpha is strictly less than -2 and beta is strictly greater than 2, which means alpha and beta are the distinct roots, right? So distinct roots are given to us, then we need to check these conditions, right? There is a very beautiful remark written over here, which is very important, that states, let fx equal to ax²+bx+c, where a is strictly positive. Then, number 1, if the discriminant is greater than equal to 0, then f of k is positive. Now, what is k? K lies between the roots of fx equal to 0, right? Second, if discriminant is strictly positive, then f of k is strictly less than 0, right? So please keep in mind these two important remarks. In our case, we are having the equation ax²+bx+c equal to 0, where a is strictly positive, and the given roots are with the conditions that alpha is strictly less than -2. So we are having the alpha, let's say, about here, and beta is strictly greater than 2. So let's say beta is at here, right? Which means we are having the two distinct roots, right? So the equation has two distinct roots. If the equation is having the two distinct roots, what can you say about the discriminant then? For the two distinct roots, discriminant is always, yes, positive, strictly positive, right? So discriminant is positive. That is, what is discriminant? It is b square minus 4ac. This is strictly positive. Reason? Alpha and beta are distinct roots. Right? Okay. Second is, what can you say about the function ax²+bx+c? Is this function strictly positive or negative? It should be positive or negative. According to the remark, if the discriminant, please read this second remark. If the discriminant is positive, then f of k is strictly less than 0. What is k? It is the real number that lies between the roots of fx equal to 0. And what are the roots of fx given to us? That is alpha and beta. So, secondly, f of x. Can I write f of x instead of f of k? There in the remark, k is written over here. But here I am using fx only because x is what? X is lying between this alpha and beta for this equation. So x lies between alpha and beta, right? Okay. So second we say that the function fx, that is ax²+bx+e, this function should be, yes, strictly negative for x lying between alpha and beta. This is what the remark 2 says. Alright. Now since if I work on this number 0, 0 is lying between alpha and beta. So let's check. What is f of 0? F of 0 is a into 0 square plus b into 0 plus c. That is equal to 0 plus 0 plus c, which is c. Because 0 is lying between alpha and beta, so f of 0 that is equal to c is strictly negative, right? So we got that c is strictly negative. Is it okay? Alright. If we work on another numbers, that is for -1 and 1. these two are also lying between alpha and beta. Let's work on this. Because alpha is strictly less than -1 and beta is greater than 1, which means 1 and -1 lying between alpha and beta. So finding f of -1, that is a into -1 square plus b into -1 plus c, that is equal to a minus b plus c. So this value should be strictly negative, right? According to the second remark. And what is f1? It is a into 1 square plus b into 1 plus c, that is equal to a plus b plus c. This is also strictly less than 0. Now we are getting a minus b plus c strictly less than 0 and a plus b plus c strictly less than 0. So from these two results, what we say that? We say that a plus mod b plus c is strictly less than 0. Right? Okay. Let's move on to now -2 and 2. Because -2 and 2 are also lying between alpha and beta. So let's check the result for these. F of -2 is a into -2 square plus b into -2 plus c, that is equal to 4a minus 2b plus c. And what is f of 2? It is a into 2 square plus b into 2 plus c, that is equal to 4a plus 2b plus c. Now this is strictly less than 0 and this is also strictly less than 0 according to the remark. And also we are having negative sign with 2b and a positive sign with 2b, right? So from these two we say that 4a plus mod of 2b plus c is strictly less than 0. So marking this result and this result, it also see strictly less than 0, this result and this result. Now let's check the options. So first option, discriminant, strictly positive. This is true. We have proved this. C strictly less than 0. This result also has been proved. Then is a plus mod b plus c strictly less than 0. This is also true. And 4a plus 2 mod b plus c strictly less than 0. This is also correct. So all the 4 options are correct. Thank you.